I would like to provide an overview of the Kindle book written by Mr. Shigehiro Nakamura, Strengthening Quality Assurance to the Maximum, which is implemented by all participation quality improvement and guarantee. As everyone watching this video already knows, the IS 9000 series is an international standard that specifies a method for improving quality through full participation and emphasizing quality assurance. This method specifies many requirements for measures to improve quality in stages, as shown in this diagram. In this figure, the IS 9000 series emphasizes quality assurance as an activity that guarantees quality in the form that a company has promised to customers and achieves customer satisfaction. Therefore, this book introduces how to effectively utilize ISO 9001 as a measure to ensure quality assurance of quality improvements. Also, although this video does not cover it, it also introduces compliance issues that arise when quality assurance is neglected, along with numerous case studies, so please refer to them. An important aspect of quality assurance is the positioning of standardization. This book is an analysis of the pre-standardization measures that Mr. Nakamura obtained during his 4 years of working with 21 leading Japanese companies' total zero-defect study group we called TZD group in the JMA to develop specific measures for zero defects and zero complaints. The study group concluded that adherence to standardization is the prevention of defects. The reason for this is that, as shown in this diagram, 1 in 30 incidents will turn out to be a defect. Therefore, the TZD study group first based its measures on the recognition that zero defects cannot be achieved by waiting for defects to occur and then eliminating them. To eliminate defects, it is necessary to identify the causes of defects and take measures to eliminate them. Therefore, they implemented improvements to eliminate the causes using the method on the right side of this diagram, defined the results of the improvements as standardization, adhered to it, and demonstrated the results of zero-defect production to the industry. As you all already know, the left side of this diagram is the improvement procedure, or QC story, that embodies standardization. The right side shows the activities that adhere to standardization and promote quality assurance. Quality assurance depends on the degree of adherence to standardization, which is the best way for manufacturing that is pursued in the factory as the best way. However, utilizing standardization has many problems, as shown in the diagram. Therefore, the TZD research group has decided on JIT standardization, which is a standardization that can be reliably adhered to and is also easy to adhere to. There is a lot of know-how here, so I recommend that anyone who needs to take measures should read this detailed document. This is one example of how standardization was implemented and maintained by everyone on the manufacturing floor. This case was an issue that occurred when Mr. Nakamura was working at a company. As is the case in every factory, the factory manager often spoke about the importance of standardization at this factory. The employees had also learned and understood its importance, but one day, Mr. A produced a defect, causing the customer's production line to stop. In many companies, sales and factory management handle customer complaints. However, it was difficult to convince customers that the measures had to be followed to comply with standards, so Mr. A, who had produced the defect, went to apologize to the customer and explain the measures that had been taken. Mr. A, who was sent to deal with the complaint, was trusted by everyone at the factory and excelled in product manufacturing. Naturally, he had no experience dealing with customers, and since this was his first time dealing with customers at the factory, he underwent extensive training before heading to the customer's manufacturing site. Mr. A worked at a factory delivering production goods to a customer. The customer's production line was making an important small part from those production goods. Mr. A enthusiastically explained the company's defect prevention measures and the status of subsequent standardization. As a result, the information was clearly conveyed to the workers on the manufacturing floor, and he successfully gained their understanding and trust in the measures being taken at Mr. A's workplace. Furthermore, Mr. A listened to the customers' detailed requests for the production goods they were manufacturing. As a result, in addition to the quality of the products they had delivered, they requested that it be easier to feed materials into automated machines. Mr. A immediately brought this request back to his factory and asked the factory staff to take measures. The improvements he made resulted in increased sales of his production goods. In Japan, the saying goes, "Post-process is the customer." This case is one in which Mr. A visited a downstream process across companies. Mr. A shared this experience with the manufacturing staff at his factory, and as a result, the factory workers' attitude toward quality assurance and customer focus improved, and in a short period of time, the factory achieved quality improvements that exceeded those achieved through lectures by the factory manager and quality training. In Japan, the idea that post-process is the customer has long been applied to everything from sword making to Japanese sweets and furniture. For this reason, the book explains in detail the importance of this idea. Standardization consists of technical standards that require compliance with physical conditions such as temperature, speed, strength, and chemical reactions, and process standards that are optimal for the person performing the work. Everyone has their own unique characteristics, such as physique, eyesight, knowledge, and experience. Process standards should be applied in a way that is optimal for each individual. For this reason, process standards should be optimized for each individual. This book provides examples of specific measures and their effects, so please refer to them as well. I have introduced the idea that compliance with standardization is the foundation of quality assurance, and that measures that are tailored to the characteristics of each individual are effective. As a concrete example of this, as shown in the example in the figure, many companies in Japan are already using IT to introduce a number of examples of measures, including traceability. Compliance with standardization is the foundation of quality assurance, and audits are a way to verify this. However, audits are meaningless if they do not reflect the actual situation on a daily basis. Mr. Nakamura therefore introduced this type of audit method, as well as an audit method that accurately and reliably leads to improvements in the unlikely event of a problem. In fact, he used this method when supporting companies in their defect countermeasures, and was able to eliminate over 85% of all defects in a short period of time. This audit method is effective not only in improving the level of compliance with standardization among employees on the manufacturing floor, but also in improving the content and use of standardization by utilizing the actual situation on the manufacturing floor, making it an effective method for improving the level of quality assurance with everyone's participation. Mr. Nakamura has developed another effective routine audit method, which he has used at various companies, with great success. In the case of a general audit, as shown at the top of the diagram, it is conducted under the assumption that the production situation at the factory remains the same between audits. This means that it is difficult to grasp the actual situation on the ground regarding changes in the state of compliance with standardization or compliance. In contrast, as shown at the bottom of the diagram, the decoy method is a sampling inspection method that can be carried out by everyone on the ground as if it were a game. If a problem is discovered using this method, funds are awarded to the person involved. This funding is used from the factory's proposal award funds, but it is far cheaper than the costs of measures such as awarding prizes to those who take measures after a defect is discovered, or the costs of quality-related education. Thank you for watching this long program. I have explained the main points of this book to you so far. This book is a Kindle book, so Prime members can read it for free. I hope you will find this book useful.